Welcome to the AXA Engineers Podcast, episode 26. Get ready to fast track your understanding, because today we're doing a deep dive. We're really digging into some critical challenges in modern civil engineering.
That's right. We'll be looking at how, moving beyond the standard ways of doing things, especially with things like stormwater management, is crucial.
Exactly. Not just fixing problems, but actually reshaping our infrastructure, turning those old liabilities into real lasting assets.
And a big part of that is how the right kind of partnership, specifically with specialized civil engineering outsourcing, makes these sort of cutting-edge solutions achievable.
Okay, let's unpack this. And hey, as we go through this, we really want to hear from you. What clicks, what questions pop into your head about your own work, or maybe just the future of infrastructure? Drop a comment below, or follow us for more insights after the show.
The hidden costs of conventional civil engineering, why good enough isn't good enough.
We've all seen those stories, right? Maybe even experienced it firsthand. Those sudden floods, eroded riverbanks, infrastructure just failing, seemingly out of the blue.
Yeah, comes as a shock.
It really does. You see a new development, looks great, everything's signed off, all the permits in place, met the minimums, but then maybe just a few years later, disaster strikes.
And you're left wondering how.
Exactly.
Yeah.
You're talking huge costs, reputations damaged, environmental fines maybe. So you kind of wonder, how could a design that ticked all the boxes, got all the approvals, end up being so, well, fragile?
It's a really key question. And what's fascinating, or maybe alarming here, is that scenario isn't just a what if. It's happening more and more. And it really stems from some deep-seated limitations in how things have traditionally been done in civil engineering, especially like you mentioned around stormwater.
Right.
For a long time, honestly, many firms just saw stormwater design as, well, a regulatory hurdle, something you had to do to get the permit.
Just another box to check.
Precisely. The focus was all on management and minimization, get rid of the water. But that mindset, that sort of just enough to pass thinking, it doesn't just miss opportunities to actually add value. It, more critically, exposes everyone, the firm, the client, to massive and, frankly, foreseeable risks later on. It's a bit of a flawed foundation thinking about water that way.
Yeah, it really boils down to that traditional view of water in, say, an urban setting, doesn't it?
Yeah.
Like, it's just waste, something to get rid of, quick.
Exactly. The standard method was always treat stormwater like it's a waste product. Unwanted, get it off the site fast.
Lots of pipes.
Lots of pipes, culverts, channels, all designed to whisk that water away, usually straight into the nearest river or stream.
Yep.
And look, on the surface, maybe that seems efficient or, cheaper in the short term.
Seems like the simple solution.
Right. But that whole perspective, that way of thinking, it actually builds in significant risk right from day one. Risk that often isn't really acknowledged. Especially now, with climate change, with cities growing so fast, that old model, it's proving to be pretty unsustainable. We're basically building systems for yesterday's weather patterns, not for what we're seeing now or what's coming.
So, okay, even if a design meets all the codes, gets the stamp of approval, that compliance can be, well, almost dangerously misleading. Like there's a gap between code compliant and actually being resilient.
That's a perfect way to put it. Deceptive compliance. A design can absolutely tick every single box for the minimum standards, get that permit. But it can be profoundly misleading because the assumptions behind those standards often create a system that's just practically fragile. It critically fails to account for two huge interconnected factors that are changing everything.
Okay, what are those?
First, you've got the weather itself. Extreme events are becoming more frequent, more intense. That whole 100-year storm idea.
Yeah.
It's almost meaningless now in some places. It's happening every decade, maybe even more often.
Yeah.
What used to be extreme back in, say, 1980 might just be a bad storm today.
Right. The baseline has shifted.
Completely. And traditional designs, based on that old historical data, they just can't cope. They weren't built for this level of intensity.
Okay, that's the first one. What's the second?
The second is the landscape changing around the project. Think about regional development. More houses, more roads, more parking lots upstream.
More hard surfaces, impervious surfaces.
Exactly. All that concrete and asphalt replaces natural ground that used to soak up water. So now, when it rains, the water runs off faster, and there's more of it. Way more.
Like turning a sponge into a sheet of plastic.
That's a great analogy. It fundamentally changes the hydrology of the whole watershed. And again, those old design methods relying on a historical rainfall, they just don't capture that cumulative impact.
So you have more intense storms hitting surfaces that shed water faster.
and you get what we call a latent vulnerability. The system looks fine on paper. It met the old theoretical storm standard, but that standard doesn't match reality anymore. It's like a ticking time bomb built right into the infrastructure, just waiting for the right storm to set it off and expose just how inadequate it really is.
Wow. That really drives home the human side of this too, doesn't it? It's not just about numbers on a spreadsheet. It's about communities, people's homes, their safety, and that loss of trust when things fail.
Absolutely. It's devastating on multiple levels.
So when that bomb, as you called it, finally does go off, when a really severe storm hits a system with these latent vulnerabilities, what does that actually look like? On the ground, what happens?
Well, it's not usually just one thing failing. It's a cascade, a domino effect.
Good.
First, the sheer volume and speed of the runoff just overwhelm what the system was designed for. Those undersized pipes, they surcharge.
Meaning they fill up completely, under pressure.
Exactly, like a blocked artery. The water has nowhere to go through the pipes, so it forces its way out elsewhere. Manholes literally pop open. Sometimes you see them shoot feet into the air.
Seriously.
Oh, yeah. Spewing water, sewage sometimes, all over streets, into properties, widespread flash flooding across the development, you can imagine. Entire neighborhoods underwater, basements ruined, roads impassable. Just chaos.
Nightmare scenario.
And it doesn't stop there. That high-velocity water shooting out of the overwhelmed system, it needs to go somewhere. It carves out downstream channels, causing severe bank erosion.
It was destroying the landscape, too.
Absolutely. Destabilizing land, wrecking habitats, maybe even threatening buildings nearby. And at the same time, that initial rush of water, the first flush.
The really dirty stuff.
Yeah, the stuff that washes all the accumulated grime off the streets and roofs.
Yeah.
Oil, grease, sediment, metals, bacteria. Normally, a functioning system would treat some of that. But when it's
It
overwhelmed,
just bypasses everything.
completely bypasses it. That toxic soup flows directly into streams, rivers, lakes, triggering an immediate environmental noncompliance violation. We hear it from clients who, maybe inherited an older system or went the minimum route initially after a big flood. The despair is palpable. Residents, businesses, the feeling of having let the community down, it really highlights why being proactive is just so critical.
That's just awful. Thinking about the aftermath. Beyond the immediate physical damage, what are the longer-term hits? For the client, the developer, the property owner, and crucially, for the engineering firm that signed off on that design.
The impacts are severe, and they linger. For the client, the developer, the municipality, whoever owns it, the costs are astronomical. You've got repairs to property, infrastructure, roads, utilities, buildings. That's millions right there, often.
And the reputation.
Huge reputational damage. Takes years, maybe decades to rebuild that trust. Property values can tank. Future projects become harder to get approved or financed, and then there are the fines.
From the environmental agency.
Yes. Substantial non-compliance penalties for that illicit discharge, depending on how bad it was, how long it lasted. We're talking hundreds of thousands easily, sometimes millions. These aren't just slaps on the wrist. They can cripple a project budget or even an entire organization.
Wow. And for the engineering firm, the ones who designed it.
Equally profound consequences. They face immense professional liability. Lawsuits from the client seeking damages are very likely. Plus, they often get mandated to redesign and retrofit the entire system.
Under much tighter scrutiny, I imagine.
Absolutely. Much more stringent rules, intense oversight. It's costly, embarrassing, and professionally damaging. So, if we connect this to the bigger picture, this isn't just a small mistake. It's a catastrophic failure of risk management.
Right.
It exposes everyone involved, developer, engineers, residents, the environment, to incredible financial, legal, and reputational harm. It's really a stark lesson. The cheapest option up front can easily become the most expensive disaster down the road.
So it's clear it's not just like one little calculation error. It sounds like a fundamental issue with the whole approach.
Yeah.
Can we break down the specific technical mistakes? The root causes that consistently lead to these massive, costly failures?
Yeah, we can. When you do the forensic analysis after these failures, the most financially damaging issues almost always trace back to three specific, and I want to stress this, entirely preventable technical oversights. These aren't mysteries, they're concrete missteps.
Yeah, what's number one?
First, and maybe most fundamental, is inaccurate hydrological analysis, basically underestimating how much water you're actually going to get and how fast it's going to arrive.
So miscalculating the runoff volume and the peak flow rates.
Precisely. It's like designing plumbing for a house but only measuring half the fixtures. If you don't know the true scale of the water challenge, how can you possibly design a system to manage it effectively?
Then why does that happen?
Outdated data. Often, yeah. Relying on old rainfall records that don't reflect the new climate reality. Or using simplified calculation methods that just don't capture the impact of all those new impervious surfaces upstream we talked about. It's a foundational error.
Okay, so inaccurate analysis first. What's next?
Well, that bad analysis directly leads to the second problem, undersized hydraulic infrastructure. Because you thought you were dealing with less water moving slower.
You build smaller pipes, smaller inlets, smaller culverts.
Exactly. The components themselves simply lack the physical capacity to handle the actual storm flows when they hit. They're built for that outdated theoretical storm, not the real-world downpours we're seeing now. It's like putting bicycle tires on a freight truck, guaranteed to fail under load.
Makes sense. What's the third oversight?
The third is a frequent lack of integrated velocity and erosion controls. Even if the pipes could somehow magically hold the volume, if the water is moving too fast, it becomes a destructive force itself.
Right, the speed causes damage.
Tremendous damage. Traditional designs often just focus on getting the water out without enough thought to slowing it down safely before it exits the system. They fail to include things like energy dissipators, check dams, or properly designed outfalls that reduce the water speed and spread it out.
So the system itself causes erosion downstream.
Exactly. The very act of conveying the water causes massive scour, channel degradation, habitat loss. It undermines the whole point.
So these three things, bad analysis, undersized pipes, and no speed control, they work together to create the failure.
They're deeply interconnected, a trifecta of vulnerability. They combine to create systems that are almost designed to fail under real-world stress. And the key takeaway here is that these are predictable. These are entirely preventable liabilities that end up costing projects millions and causing lasting harm.
It really sounds like that whole approach, the reactive problem solving, waiting for something to break and then scrambling. It's not just inefficient, it feels completely obsolete and, frankly, dangerous, high risk.
It absolutely is. That reactive stance, just aiming for minimum code compliance and then dealing with failures after they happen, it's just not viable anymore, not in our changing world. The industry, the climate, the communities, they all demand a proactive, integrated approach now. The focus has to shift away from just ticking compliance boxes, which we've seen can be dangerously misleading, and towards comprehensive risk mitigation right from the very start of the design process.
Building resilience in from day one.
Exactly. Addressing these known failure points before they can cause problems. That's how you ensure long-term performance, protect the environment, and shield everyone involved from these predictable, preventable, and incredibly costly liabilities. And, this commitment to proactive, value-driven design and having the advanced tools to actually do it, that's precisely where AXA Engineers comes in. It's really where we stand apart, offering a fundamentally different approach through our specialized civil engineering outsourcing services.
AXA Engineers' vision, transforming stormwater into a strategic asset through integrated management.
Okay, so if the old way is a ticking time bomb, let's talk solutions. What does a modern, truly resilient approach look like? This is where I think it gets really interesting. Because AXA Engineers isn't just like patching up the old problems. You guys are fundamentally redefining how we should even think about these civil engineering challenges, especially stormwater.
That's the goal.
Turning what everyone saw as a burden, a liability, into a genuine strategic asset. That's a huge shift. It's not just about stopping floods anymore, is it? It's about creating actual value.
That's absolutely right. At AXA Engineers, the whole game changes because of how we view water itself. It's a foundational shift. Instead of seeing stormwater as just, nuisance water, waste that needs to be removed.
Get rid of it.
Right. Our integrated water management model sees it completely differently. We treat it as a valuable resource, something to be leveraged.
Okay, how does that work in practice?
Well, it's not just a nice idea. It's a deeply strategic, data-driven approach. We use advanced modeling, very sophisticated stuff, to develop systems that aren't just resilient to today's pressures, but are also harmonized with the site itself. They can even contribute positively to the local ecosystem.
So going beyond just do no harm.
Exactly. The core objective isn't just preventing problems anymore. It's about actively maximizing the functional benefits, the ecological benefits, and even economic benefits. This significantly strengthens a project's viability, its appeal, its value over the long haul.
Can you give an example?
Sure. Imagine a system that obviously prevents flooding, that's table stakes, but it also creates green spaces, enhances local biodiversity, helps recharge the groundwater aquifers, maybe even becomes a park or a community amenity. That's the kind of lasting value we aim to build. And this proactive integrated thinking is really a core benefit that AXA Engineers delivers through our specialized civil engineering outsourcing capabilities.
Now, I know a key piece of technology that AXA Engineers uses to make this happen is something called a digital twin. That sounds very futuristic. For anyone listening who isn't familiar, can you break that down? What is it, and why is it such a game changer for civil engineering?
Yeah, the digital twin is absolutely central to what we do at AXA Engineers, a real differentiator. And it is transformative. The simplest way to think about it, it's like a hyper-realistic flight simulator, but for your project's water system.
Okay.
So instead of just static blueprints or maybe some basic 2D plans, we build a dynamic, comprehensive, data-rich virtual replica, a digital copy of your entire project site and its surrounding watershed.
So more than just a 3D model?
Oh, much more. It's not just geometry. It's a simulated world that constantly integrates tons of real-world data, super precise topography, different soil types and their properties, current land use, projected future land use, all the existing pipes and channels, planned infrastructure, even future climate projections.
Wow, okay. That's comprehensive.
It gives us an incredibly realistic baseline to test everything, every design option. Unlike those traditional methods that, like we said, often just use static calculations based on old rainfall data, which can be so misleading.
Right, the outdated stuff.
The digital twin lets us see exactly how water will move, how it will interact with the site, how the proposed system will manage it. Under dozens, hundreds of different scenarios, we can anticipate how the system will behave, whether it's a light shower or, a massive hurricane-level storm, not just some theoretical average storm.
So you can really stress test the design virtually.
Precisely. And the critical thing is, it's not a one-off analysis. It's a living tool. We constantly update it, refine it with new data, new insights, all the way through the design process. This constant feedback loop, this iteration, ensures our designs aren't just robust, they're highly optimized for efficiency, for cost-effectiveness, for long-term performance. That level of foresight and refinement, that's a hallmark of the kind of advanced civil engineering outsourcing AXA Engineers provides.
So with this incredibly detailed digital twin, AXA Engineers can essentially play out countless what-if scenarios, really put a design through its paces digitally before anything gets built. That sounds like it gives you predictive power for resilience that was just impossible before. What are some of the maybe surprising or really tough what-ifs that the digital twin has helped your teams figure out, things you couldn't have caught otherwise?
Oh, absolutely. That's exactly the power of it. Predictive simulation for unprecedented resilience. Inside that sophisticated virtual environment, our teams run simulation after simulation. Dozens of hydrological scenarios, everything from those frequent, maybe small nuisance storms, right up to the really rare, super high-intensity events, the kind of storms that the latest climate projections say we need to be ready for.
So you're genuinely designing for the future, not just the past.
That's the mandate. We have to. And these simulations are absolutely vital for rigorously testing and then optimizing all the different tools in our toolbox, the stormwater control measures, or SCMs.
Okay, like what kind of SCMs?
Well, for instance, we can model the precise effectiveness of things like 1. Permeable pavements. These aren't just nice-looking driveways or parking lots. They're engineered systems, special concrete or asphalt over layers of specific aggregates that let rainwater soak right through into underground storage instead of running off.
Okay, so less runoff helps groundwater.
Exactly. Reduces peat flows dramatically, recharges groundwater, can even filter out some pollutants, and the digital twin lets us figure out the exact aggregate depth needed, the right infiltration rate, to handle maybe a small 2-year storm versus a massive 100-year event, balancing the cost and performance perfectly.
Right.
2. Infiltration trenches. Basically gravel-filled ditches designed to collect runoff and let it soak slowly into the ground. Our models help determine the perfect length, width, depth, considering the soil type, the slope, how much area drains to it, ensuring they won't clog up or get overwhelmed. 3. Bioretention basins, or you might know them as rain gardens. These are specially designed shallow depressions in the landscape. They use engineered soil mixes and specific types of plants, often native ones, to filter pollutants and absorb stormwater slowly.
Ah, so they treat the water quality too.
Big time. And the models help us specify everything. The best plants for the local climate, the right soil mix, the exact slope and depth for maximum pollutant removal and water retention. Plus, we can integrate them aesthetically, make them look like intentional, attractive landscaping. 4. Green roofs. Putting vegetation on roofs. These systems capture rainwater, release it slowly, reduce runoff, and they also provide insulation benefits for the building. The digital twin helps us calculate the precise water holding capacity needed, any structural implications, making sure they contribute meaningfully to the site's overall water management plan.
It sounds incredibly detailed. You're quantifying how each of these will perform under different kinds of stress.
Rigorously quantified under all sorts of conditions. And it's an iterative process. We tweak the placement, the size, the configuration of these SCMs with incredible precision. We can find the exact best spots for those bioretention basins to catch the most runoff, or specify the perfect aggregate mix under permeable pavement that needs to handle heavy trucks, but also infiltrate water effectively. We can even simulate how different SCMs interact with each other in sequence across a site.
Ensuring the whole system works together seamlessly.
It has to be integrated. That's the key.
Hmm.
A truly efficient and resilient system.
Wow, that level of detail, that predictive capability. It sounds like it must go way beyond just meeting today's regulations. You're really aiming higher, creating infrastructure that isn't just compliant today, but genuinely robust for the future. Future-proof almost.
That's absolutely the goal.
Yeah.
Always. We aim to fine-tune these designs to exceed the regulatory minimums for water quality treatment, for quantity control. It's not about just scraping by.
So satisfying things like the Clean Water Act, but going further.
Much further. Setting measurable targets and demonstrating through simulation that we can hit them. Targets for, say, removing 90% of certain pollutants, or reducing the peak flow rate by 70% during a major 25-year storm event. This isn't just theoretical. We provide the data, the proof. This level of proven performance ensures the system works reliably long-term.
Okay, but there must be trade-offs, right? How do you balance pure engineering performance with, say, long-term maintenance or making sure it actually helps the local ecology? That sounds complex.
It is complex. It's a critical balancing act. That's where the real expertise comes in. For example, designing a great bioretention basin isn't just about hydrology. It needs plants that are adapted to the local climate. Right, plants that will thrive with minimal upkeep, but also genuinely enhance the site ecologically. Maybe support pollinators, provide shade, look good.
Right, it's not just a ditch.
Not at all. Achieving that perfect blend, top engineering performance, low long-term maintenance, real ecological benefits, it requires truly specialized expertise. You need civil engineers talking to landscape architects, talking to environmental scientists. And you need sophisticated analytical tools like our digital twin to manage all that complexity and explore the trade-offs effectively, delivering solutions that are genuinely sustainable, cost-effective, and beneficial over decades. That meticulous optimization. That's where AXA engineers' deep experience in specialized civil engineering outsourcing really makes the difference.
It definitely sounds like this requires more than just standard software, a serious arsenal of cutting-edge tech, and crucially, a team that really knows how to use it all together. What kind of advanced tools are in the AXA engineer's toolkit to make all this happen?
You're right. It demands a powerful, integrated, and constantly evolving technology stack. And equally important, engineers who are highly skilled in deploying it. AXA Engineers uses a whole suite of licensed software, tools chosen very carefully for their accuracy, their simulation power, and how well they work together.
Can you give some examples?
Sure. For the detailed site modeling the grading, calculating earthwork volumes, getting that precise 3D terrain model right, our teams rely heavily on industry standards, like Autodesk Civil 3D. That really forms the geometric backbone of the digital twin.
Okay, the basic site layout.
Exactly. Then, for the really complex simulations, predicting how water actually flows, how it behaves across the landscape, how it interacts with pipes and channels, we use advanced, extensively validated modeling tools. This includes the EPA's Stormwater Management Model, SABUMM. It's essential for dynamic simulation running scenarios over long periods, modeling runoff generation, how pollutants move, how water routes through complex pipe networks. It captures those cumulative effects.
Right.
We also frequently use the U.S. Army Corps of Engineers HAC-ARES model. That's particularly powerful for analyzing open channels, rivers, bridges, culverts. It helps us understand how our site design connects with existing waterways and predict any potential flooding impacts upstream or downstream.
So you're using established, trusted tools?
Absolutely. But we go beyond just using them off the shelf. This is crucial. We also develop and employ proprietary scripts and custom algorithms.
Ah, okay. In-house tools.
Yes. These scripts integrate seamlessly with the commercial software, but they allow us to perform multi-objective optimization. What that means is our teams can rapidly evaluate hundreds, maybe even thousands, of different design variations.
Wow.
Yet testing them against multiple criteria simultaneously like cost, hydraulic performance, environmental impact, constructability, this automation lets us zero in on the solutions that are truly the most effective, the most resilient, and the most cost-efficient, much faster than traditional methods would allow. It's a huge advantage in pushing design boundaries.
That makes sense. Using automation to explore more options.
Exactly. So this whole technology stack, Civil 3D, SWMM, HEC-RAS, plus our custom tools combined with the deep expertise of our engineers, it ensures every system we design isn't just compliant today, it's optimized for demonstrable performance and cost-effectiveness across its entire lifespan. It's about engineering solutions built to last, built for the future climate. Now, naturally, when we talk about all this sophisticated modeling and tech, the next question we often get from potential clients is, this sounds amazing, but how do we access this? Do we need to build our own giant R&D department?
Right. How is this actually delivered?
And that's a critical point. It leads directly into how we deliver this value through AXA Engineers' strategic approach to specialized civil engineering outsourcing.
The AXA Engineers Advantage, strategic civil engineering outsourcing.
Yeah, that's the perfect segue because honestly, this level of sophisticated design, the digital twins, the advanced analysis, it sounds incredibly powerful, but also really resource-intensive. So for a project developer, or maybe a municipality, or even another engineering firm that doesn't have this in-house, how does it actually translate? How does it become efficient, accessible, and help you deliver your project smoothly? This seems to be where the AXA Engineers model of strategic civil engineering outsourcing really shines. It's not just about getting work done right, it's about getting the best possible work done efficiently.
Exactly. Our whole operational model at AXA Engineers is built for that, delivering superior results with maximum efficiency. We achieve this by leveraging global collaboration in a really smart way. A key element is our dual team working model.
Dual team, how does that work?
It basically enables continuous work on a project. We have teams strategically located across different time zones, allowing for continuous simulation runs, ongoing analysis, and constant collaboration. Think about it. Your project is essentially being worked on almost 24/7.
Okay, so work happens while I sleep.
Pretty much. We structure our operations with carefully managed overlapping shifts. This means our global teams stay seamlessly aligned with our clients' normal working hours, no matter where the client is based.
Ah, so you still get that real-time interaction.
Absolutely. But the work continues progressing significantly even outside those hours. The benefit for clients is huge. Dramatically accelerated design iterations, much faster incorporation of feedback, and the ability to consistently meet even the most demanding project deadlines without ever cutting corners on quality. This continuous workflow is a major advantage of specialized civil engineering outsourcing with AXA Engineers. It just eliminates costly downtime and keeps the momentum going incredibly fast.
That makes a lot of sense for timelines. Now I have to ask, because I know it's always a top concern whenever outsourcing comes up, data security, protecting intellectual property. How does AXA Engineers handle that? That trust factor has to be rock solid, right?
Oh, it's more than a concern. It's fundamental. It's a non-negotiable foundation of trust, and we treat it with absolute seriousness at AXA Engineers. We've implemented robust, multi-layered data security protocols and strict anti-leakage measures across every part of our operation.
So it's built into the system.
It's deeply embedded. This isn't just a policy on paper. It's in our infrastructure, our processes, our culture. We maintain rigorous compliance with international legal standards and data protection regulations, things like GDPR and similar frameworks globally. This ensures the absolute protection of all client intellectual property, sensitive project data, everything.
What does that look like practically?
Our secure digital work environments are fortified. We use advanced encryption, very strict access controls based on roles, continuous monitoring for any anomalies, and regular independent third-party security audits to validate everything. And importantly, our agile operational framework, the one that delivers efficiency. It's also designed for secure, controlled changes. Refinements can happen efficiently without ever putting sensitive data at risk or causing project delays due to security hurdles. This unwavering commitment to security and confidentiality is how we build that strong confidence and trust. It gives our clients using AXA Engineers for civil engineering, outsourcing total peace of mind that their most valuable information is meticulously safeguarded.
Okay, that's reassuring. So you have this proactive modeling, this advanced design capability, secure collaboration happening almost around the clock.
Yeah.
How does all that impact the regulatory approval process? Because let's be honest, navigating approvals can be a huge headache, adding time and cost. Does this approach help smooth that out and build confidence with the agencies?
It makes an enormous difference. Transformative, really, especially when dealing with complex environmental or land development regulations. Our whole proactive modeling and data-driven approach directly translates into significantly reduced project risk. And that, in turn, leads to a much smoother, more predictable journey through the regulatory maze.
So,
Well, instead of submitting designs based mainly on, say, theoretical calculations or generalized assumptions, the kind of thing that often invites pages of questions from reviewers.
right, the back and forth.
Exactly. AXA Engineers submits a performance-based report. This report is backed by extensive verifiable simulation data from the digital twin. It doesn't just state our design meets the minimum standard. It demonstrates precisely how the system will perform under a whole range of conditions.
Yeah.
It quantifies the pollutant removal rates, the peak flow reduction, the ecological benefits. It shows the work.
Providing clear evidence.
Clear, transparent, evidence-driven proof. And regulators really appreciate that. It builds immense confidence among all stakeholders, the local planning board, state environmental agencies, federal bodies if involved. They can see the rigor. They know the design has been thoroughly stress-tested against realistic future scenarios.
So fewer questions, fewer delays.
Significantly fewer requests for additional information, which saves a ton of time and money. It drastically lowers the likelihood of needing costly redesigns late in the game or facing those hefty non-compliance penalties later on. If we connect this back to the bigger picture, partnering with AXA engineers for specialized civil engineering outsourcing effectively streamlines the approval process. It reduces that bureaucratic friction and provides profound peace of mind for the client. It turns those regulatory requirements from potential roadblocks into measurable targets that we confidently demonstrate are being met and often exceeded.
It really crystallizes the idea then. Partnering with a specialist like AXA Engineers isn't just about delegating tasks or getting extra hands. It's about strategically injecting a deep, specialized knowledge base and cutting-edge technology directly into your project team, without needing the huge investment to build all that capability yourself. It's like amplifying your team's potential.
That's precisely it. That's the core value proposition of strategic civil engineering outsourcing with AXA Engineers. When you partner with us, you instantly integrate over 15 years of highly targeted, cutting-edge expertise right into your project ecosystem.
More than just staff augmentation.
Way more. It's about embedding deep domain knowledge in areas like advanced hydrological modeling. It's about gaining access to that powerful suite of proprietary and licensed technologies we talked about. And it's about leveraging a proven, highly efficient global workflow. This kind of collaboration has the power to genuinely transform challenges, those complex technical problems, those demanding regulations, into real opportunities.
Opportunities for what?
Opportunities for sustainable innovation in design, for finding significant cost efficiencies, both upfront and long-term, and for creating projects that have demonstrably enhanced appeal and lasting value. It means your project isn't just compliant, it's optimized, it's inherently resilient. It's measurably more valuable because you've tapped into this deep pool of specialized talent and technology from AXA engineers. Talent that truly understands the nuances, the complexities, and the future demands of modern civil engineering. It's fundamentally about building smarter, safer, and more valuable infrastructure from the very beginning.
The lasting value. Why AXA Engineers makes your project an asset.
Okay, let's bring this all together. What does this fundamentally mean for you, the listener, for your projects? We've talked a lot about dodging bullets, avoiding those costly failures, the penalties, the headaches. But the really exciting story here, I think, is about building something genuinely better, something that really stands out as thoughtful, forward-looking engineering. With the AXA Engineers approach, it sounds like your stormwater system, maybe even the entire project, truly becomes an asset. Not just something you have to deal with, but something that adds value. It's a total shift in perspective, isn't it?
It absolutely is. A complete transformation from seeing it as a burden to recognizing its potential as a benefit. And the returns you get from AXA Engineers' integrated approach, delivered through our civil engineering outsourcing model, they go way beyond just preventing problems or meeting basic codes. The value is multifaceted.
Okay, like what? What are the key value adds?
Well, first, there's significant ecological enhancement. Our systems aren't just designed to manage water. They're designed to actively work with nature.
How so?
This means intentionally providing valuable green space, especially in urban or heavily developed areas where it's scarce. It means demonstrably improving the local ecology by drastically reducing the amount of harmful pollutants washing into our rivers and lakes. And crucially, many of these systems actively help recharge local groundwater tables, which is becoming critical in many regions.
So the infrastructure itself becomes environmentally beneficial.
Exactly. Imagine a development where the stormwater infrastructure is actually a beautiful, functional series of rain gardens or a green corridor that filters water naturally, supports local plants and insects, and even helps cool the area down in the summer. That kind of tangible sustainability resonates incredibly strongly today. With communities, with regulators, with investors, it adds a layer of genuine environmental stewardship that people increasingly value. It's building for the environment, not just around it.
And those ecological benefits are clearly huge, invaluable, really. But I assume they're also very clear, hard-nosed financial returns, too. Things you can measure on the bottom line.
Oh, absolutely. There's a very clear and demonstrable return on investment, ROI, that comes from this approach. First off, the robust, optimized designs lead directly to improved safety for the community living or working there, and for the infrastructure itself. Fewer floods, less erosion risk, that alone can translate into things like lower insurance costs, and obviously avoiding those catastrophic repair bills from major failures.
Right, avoiding the disaster costs.
Huge savings right there.
Yeah.
Critically, we also see the virtual elimination of costly retrofits down the line. Conventionally designed systems, built to yesterday's standards, often will fail as the climate changes or development continues upstream. Fixing them later. That can cost 2, 3, even 4 times the original installation cost. It's a massive future liability.
So designing it right the first time saves enormous future expense.
Enormous. We're locking in long-term savings by designing for future conditions now. And furthermore, because of the thoroughness of the design process, the precise optimization using the digital twin, the careful selection of materials and vegetation, clients benefit from significantly reduced long-term maintenance costs. Things are designed to function efficiently with less intervention. These aren't small savings. Added up over the 20, 30, 50-year life of the infrastructure, they are substantial, measurable financial advantages. They contribute directly to a healthier project budget long-term. And again, achieving this proactive value creation is the direct result of leveraging the specialized expertise through AXA Engineers' integrated civil engineering outsourcing model.
So you've got a project that's safer, more resilient, costs less to maintain over time, and is genuinely better for the environment. That package must also make the project itself significantly more attractive in the marketplace, right? Sounds like a real competitive edge.
That's exactly right. A well-designed, demonstrably resilient, and ecologically beneficial system contributes powerfully to enhance project appeal and marketability. Think about it. In today's market, whether you're selling homes, leasing commercial space, or even seeking community approval for a municipal project, people are more discerning than ever.
They're looking for quality, sustainability.
They are. A project that can proudly showcase its long-term resilience, its commitment to environmental quality through things like integrated green infrastructure, maybe its lower utility costs due to water reuse, its beautiful and functional green spaces, and its low long-term maintenance burden. That project stands out dramatically.
It becomes a key selling point.
A huge differentiator. It can attract higher value tenants or buyers, lead to quicker sales, garner stronger community and political support. People want to live, work, and invest in places that demonstrate foresight, responsibility, and genuine sustainability. The AXA Engineers approach helps your project not just meet the baseline expectations, but truly exceed them, positioning it as a highly desirable, future-proof asset in the market. So ultimately, this whole evolution in stormwater engineering, the way AXA Engineers practices it, it just fundamentally proves a key point. The most effective, the most enduring, and ultimately the most valuable designs are the ones that stop fighting water and start treating it as a resource, as a partner.
A paradigm shift.
It really is. Moving away from just ticking those compliance boxes towards this holistic, integrated management approach. That's precisely where leading firms create lasting value. And leveraging expert specialized civil engineering outsourcing from AXA Engineers is the smartest, most efficient way to make that shift, decisively mitigating long-term risk and maximizing project potential. It's about moving beyond just constructing pipes and ponds and toward cultivating truly thriving, resilient, and economically vibrant environments that will deliver value for decades.
Wow, what an incredibly insightful journey we've taken today. Really moving from those hidden dangers of sort of reactive old school engineering to the immense potential of proactive value generating civil engineering, we've really seen how AXA engineers isn't just, plugging holes or fixing problems. They're truly architecting a more resilient, more sustainable, and frankly, more profitable future for every single project they touch, using amazing tools like the digital twin, that integrated management philosophy, and delivered through their focused, specialized civil engineering outsourcing services. So, what does this all mean for you thinking about your next project, your next challenge?
Well, I think it means peace of mind. It means access to innovation. And it means gaining a really powerful competitive edge that can make your project stand out.
That sums it up well. Because in today's world, a world that demands so much more from our infrastructure, more resilience against climate change, genuine sustainability, proven long-term value, just meeting the bare minimum codes, it's simply not enough anymore. It won't lead to success. The real question you need to ask for your next project isn't just, can we build this? It's got to be, can this project thrive? Can it adapt to future challenges? Can it continually deliver tangible value and stand as a true lasting asset for decades to come, even when things get unpredictable? That future, that resilience, that lasting value, that is the future AXA Engineers builds.
So, if you're ready. If you're ready to transform your civil engineering challenges from potential liabilities into genuine opportunities for innovation, for real cost efficiency, for enduring value, if you're ready for your next project to be not just compliant, but truly exceptional, resilient, and ready for whatever comes next, then it really is time to reach out to XA engineers. Discover what 15 years of dedicated, targeted expertise in specialized civil engineering outsourcing can unlock for you and your team. Visit AXA Engineers today. Start a conversation. It could genuinely redefine your next project and lock in its success for the long term. And hey, before you click away, please do hit that like button if you found this valuable, drop a comment with your thoughts or questions, and be sure to follow us for more deep dives into the world of smarter engineering solutions.